What is the probability that you will roll an even number on a toss of a six-sided number cube? I'm not sure why they named this a six-sided number cube. It's just a die. We rolled die yesterday. Singular, it's a die. Two die is dice. So we did this yesterday. What's the probability of rolling an even number? I introduced you to two formulas yesterday on your notes, if you recall. One was theoretical probability, right, the first one, and the second was experimental. Okay? Theoretical just has to do with the thought experiment in our mind. We don't have to do anything. We just got to think about what's the probability of something occurring. Experimental is when you actually do the thing and record your trials and the successes, like we did yesterday. Remember the table? So on example 5, is this a theoretical situation or a experimental?
Theoretical.
Theoretical, because they're not asking me, hey, go and roll the die 20 times and figure out what the probability was of rolling an even number. They're just saying, look, before you even throw it, what's the probability that's going to land on an even number? That's theoretical. Here we go. The probability then, look at capital P, means probability of an even number. I'm going to put E for even. Whatever's in parentheses, you're kind of describing the event that you're interested in. Of an even number. Okay. Let's see what the formula says. The numerator on the formula says total of favorable outcomes. What is a favorable outcome in this situation?
How many numbers are even?
Even. How many even numbers? Well, let's see. There's 3, huh? We've got 2, 4, and 6. Rocking and rolling. And look at the denominator is going to be the total number of outcomes. That's 6 sides to a die. 3 over 6, huh? Look at 3 over 6. If I type that in the calculator, make it into percent, that's 50%, ladies and gentlemen. There's a 50% chance that you'll get an even number. The decimal would be 0.5. You just put a 0 on the 100 place and you're rocking and rolling. You got 50% chance. So is it likely or unlikely?
Likely.
Between look at the way your notes say it. It's equally likely to happen or not happen at 50%. It's equally likely to happen or not happen is to roll an even. So whenever you're in doubt, just go to your scale, your spectrum here. It'll tell you how likely something is. All right. Let's try number 6. Question on example 5. No big deal. No big deal. Example 6. This is a table, a probability table. I'll write example 6. And go and write next to example 6, put C video. Because I don't want you to copy this table down. This table will be accessible to you on the video that I'm recording, so you don't have to copy the table down. Just on your notes, put C video. All you got to do is go to example 6 on the video and you'll see the table. So instead of copying the table, just copy down the question. So example 6, just put C video for the table, because there's the table. And then write the question down. What is the probability that an applicant had 15 years experience with an Ivy League college education? So this is a corporation that has a bunch of applicants for a job opening. It gets very competitive out there. If you want a good job, you're going to have to compete against other applicants. And a corporation can have stacks and stacks and thousands of applicants for a job opening. And this is the numbers here. Here's the probability that some of the applicants had this much experience and this kind of degree. So right now, just write down the question and write C video. You can look at this table later, like I said. This will be all on Google Classroom. You're the employer at a corporation. You're a manager, and you have to sift through thousands of applications for the best candidate, or maybe perhaps a group of candidates to get the best employee. A lot of applicants have been submitted, and here's the breakdown of the applicants. Out of all the applicants, these are probabilities here. What percent is this probability right here? We already went over that, right? What will this be? That's 5%. So this right here means there's a 5% chance that one of the applicants had no college degree but 5 years or less experience. This is the problem. This is a 9% chance that an applicant had no college degree but 10 years experience for the job. And so on and so on and so on. Big Ten that's a type of university. The Big Ten universities, does anybody know what Big Ten universities are? Give me one. I think Alabama's a Big Ten. Clemson. There's some on the East Coast, Big Ten universities, I think. Or is it the ACC? I forget. Anyway, there are types of universities. And then Ivy League, that's the cream of the crop. Ivy League are Princeton, Harvard, Yale, Columbia, UCLA. UCLA is an Ivy League. That's my alma mater. And then you got junior college. You guys know what junior colleges are, I suppose. What's he laughing for? Mount Sac, Chaffey College, Pasadena City College, right? So, look at the question. What is the probability that an applicant had 15 years experience with an Ivy League college education? What is the probability that an applicant had 15 years experience with an Ivy League college education? 1%? Let's see. 15 years experience, Ivy League. There it is. 1% chance. That was easy. 1% probability. So this table, all it involved is converting the decimals to percents, which is ridiculously easy. I already went over that. So number 6 looked a lot scarier than it actually is. Okay? Last few here. So examples 7, 8, 9, and 10 are all referring to one table. So you're going to do the same thing for this example. You're going to write C table or C video. Okay? Here we go. So 7, 8, 9, and 10, go to write C video. Don't copy the table down, just copy the questions down. So 7 is, what is the probability that a student said basketball? Number 8, what's the problem? Actually, we're going to put what is probability. We're not doing odds here. What is the probability that a student said soccer? Number 9, what is the probability that a student said baseball? And what is the probability that students did not say baseball? So all you're doing is writing down 7, 8, 9, and 10, the question. Don't copy down this because it'll be on the video accessible to you later on Google Classroom. So number 8, we're not doing odds. So cross out the word, or just write, what is the probability that a student said soccer? Going to copy that down. Do you guys know what a survey is? What's a survey? Can someone describe to me what a survey is? What's a survey? Gonzalez, go ahead. Go ahead. A series of questions. And those series of questions are given to whom?
People that take you.
The participants that you're interested in. So look what we got here. Look what we got here. We got a survey. A group of 220 students were asked to name the sport they most like to attend. In other words, if I had tickets to a soccer game, baseball game, football game, what else we got? Volleyball. What game would you want to go to? Well, here's the spread. 220 students were asked, what sporting event would you like to go to? And now look at question 7. What is the probability that a student said basketball? There we go. P, probability. In parentheses, I'll put B for basketball. So the number of favorable outcomes, so this is experimental probability because students actually did the thing. They actually did the survey. So experimental probability, the numerator is number of successes. How many said basketball? Well, that's 40. Look at out of 220. Let me convert that puppy to a decimal and percent. So 40 out of 220. Watch me do it. 40 divided by 220. To the nearest hundred, the 8's in the hundreds place. Next to it is a 1, so this is about approximately 18%. There's an 18% chance that someone said basketball. So we're going to write approximately 18%. That was easy. So out of everyone who was surveyed, there was an 18% chance someone said basketball. Unlikely, but possible. Number 8, I'll put right on here. What's the probability that a student said soccer? Same thing. Look at this. Probability, S for soccer. We have 20 out of 220. Let me get my calculator. 20 divided by 220. We got a 9% chance. Look at the hundreds place is a 9, next to it is a 0, so it's 9%. So I got a 9% chance that someone said soccer. You know we're in the United States when soccer is lower than basketball. If this survey was done to high school students perhaps in Mexico or Europe, you know soccer wouldn't be this low. Let's try 9. Number 9, I'll put in red. What's the probability that students said baseball? Here we go. Baseball, 55, so probability, I'll put B for baseball, is 55 out of 220. Let's rock and roll. 55 divided by 220. 55 divided by 220. I get 25%, exactly 25%. Last example, and we're done with our notes. Questions so far? Number 10 is kind of weird and funky, but it still makes sense. What's the probability if someone did not say baseball? So I'm going to put NB, not baseball. How many people said not baseball? How'd you get that, Ekasan? Perfect logic. Those who did say baseball subtracted from everybody. Because those who did say baseball, if you subtracted, what's left over is those who didn't say baseball. 55 said baseball. Take the total, 220 minus 55, you get 165. Good logic. 165 are the amount of students who didn't say baseball. They said some other sport out of 220. Perfect. Let me get my calc. My calculator. 165. Adiaga, we're good? Is it 175? Let's see. 220 minus 55. Is it 55? Yeah, it's 165. So 165 divided by 220. Oops. 165 divided by 220. Rock and rolling, 75%. 75%. All right, hang tight, real quick. Before you log into the game now, I want you to win. So if you're interested in winning, you want to pay attention to what I'm about to say. There's a couple of trick questions on the game that I want to give you a heads up on.
Sure.